Section 2.4, complex numbers. Imaginary unit I. Up until now, everything that we have done has been in the real number system. Now we're going to begin working in the complex number system as well. In order to do that, we need to know how to handle the square root of negative numbers. We're going to do that through the imaginary unit I. I is equal to the square root of -1. So anytime we have a negative now underneath a radical, we can pull an I out, and that is going to then make whatever is underneath the radical a positive number and then allow us to work with it. So if I is the square root of -1, that means I squared is the square root of -1 times the square root of -1, which is just -1. I cubed then would be the square root of -1 times the square root of -1 times the square root of -1. Well, we know these first two multiplied together gives us -1. This last one is just I, so this is going to equal -I. And I to the fourth power is going to end up being I times I, or I squared, and I squared is just equal to 1. Whenever we have an exponent on I then, we should always be able to simplify it down into terms of either I, -1, -I, or 1. We should never have an exponent on I larger than 1 because we can always simplify it to something less complex. Complex numbers must be written in standard form. Complex number has a real part, which is what's out front, and an imaginary part, which is always written second. All solutions that are complex must be written in standard form. So you could see a solution written as something like 2 plus 3i. It could be something where the real stuff is 2, 3 plus 3/2 times I. If you have something like a solution to a quadratic, that is 2 plus or minus 3i all over 5. That is not standard form. You should separate that and rewrite it like this. So in other words, you should always be able to easily identify the real portion and the imaginary portion of your complex number. If you can't, it is probably not in standard form. When we do operations involving imaginary numbers, treat I as you would any other variable. So in this case, when I add these two together, I have to add like terms. 3 plus 2 is 5. -I plus 3i is 2i. Over here, same thing. Collect like terms. 2i plus -2i cancels. We're just left with -4. Here, add like terms. 3 minus a -2 becomes 3 plus 2, which is 5. 5 plus -5, that's gone. We have -3i plus I is -2i. Multiplying, follow the same rules as a variable, with the exception of, remember, if we have an exponent larger than 1 on I, it can always be written in a simpler form. In this case, I times -3i is going to be -3i squared. Then we know that I squared is just equal to -1, and -3 times -1 is 3. Here we get a FOIL situation. When we FOIL this out, first, outer, inner, and last, begin simplifying. I squared, remember, is -1, so this last term becomes a positive 3. 8 plus 3 is 11. 6i minus 4i just gives us 2i, and there's our solution in standard form. Conjugate pairs, just like any other conjugate pair, when we're multiplying, we don't need to FOIL all this out. First thing squared minus the second thing squared. Simplify, we should never have an exponent larger than 1 on I. I squared is -1, so this becomes 9 plus 5, which is 14. that? 14. 9 plus 4 is 13. Okay, simplify and write in standard form. Up until now, if we saw something like the square root of negative 9, we'd say not real and we were done with it. Now we have a way of handling that by pulling an I out. So this becomes 4 plus I times the square root of 9. Square root of 9 is 3. So do we just have 4 plus 3I? Square root of 75. Pull the I out. Simplify underneath the radical. 75 is the same as 25 times 3. Square root of 25 is 5. We're left inside still with the root 3. Okay, standard form, remember, I is written at the end. If there's a radical, I do not care if you write the I in front like this, just because if you write this like that, that would be fine. But if you write this like that, that is not going to be fine because that looks to me like the I is underneath the radical. So if you're going to write it like this, make sure you write that I clearly outside the radical. I would accept this form so you don't have to worry about whether you're going to miss a point if you do something sloppy like that and it looks like the I may be underneath the radical. 6I plus I squared. The only thing we can do here to simplify is we know I squared is negative 1. So this is the same as negative 1 plus 6I. Remember, the real part has to be first. The negative 1 we have to write before the I in that case. Rationalizing. It's important that you remember that an I is a square root. So down here in the denominator, that's like having a square root, so we need to rationalize this. How do we rationalize when we have two terms? You multiply by the conjugate. 4 plus 2I over 4 plus 2I. Go ahead and FOIL out the top. When we FOIL out the top, we get 8 plus 4I plus 12I plus 6I squared. Conjugate pairs, don't forget your shortcut. First thing squared minus the second thing squared. Begin simplifying up top. Remember, I squared is negative 1, so this becomes 8 minus 6, which is 2, plus 16I. In the bottom, that becomes 16 plus 4, which is 20. And now we need to write it in standard form, so we need to separate these. That becomes 1/10 plus 4/5 times I. There's standard form. Okay, operations involving negatives underneath square roots. You need to be careful here. Okay, a lot of students will look at this and say, well, I can multiply stuff that's underneath the radical, so that's the square root of 36, which is just 6. It's not true. You cannot multiply things underneath the radical when they are negative, because those are not real numbers, so the same properties do not apply. Here I need to pull an I out, so I get I root 3. Here I need to pull an I out, I get I root 12. Now that those are real numbers underneath the radical, or positive numbers, we can multiply those two things. So I times I gives us I squared. Root 3 times root 12 gives us root 36. Simplify, the square root of 36 is 6. So we have negative 1 times 6, which is negative 6. And notice if you just multiplied up here, we got positive 6, which would be incorrect. Letter B. Okay, so part B, we need to first change these by pulling i's out. We get root 48 minus I root 27. In this form, nothing that we can do here. So let's start breaking down these radicals. 48 is 16 times 3. 27 is 9 times 3. Square root of 16 is 4. So we have 4I root 3 minus 3I root 3. Now we do have like terms because our radical stuff matches up exactly. So I have 4 minus 3, which is 1I times root 3. Letter C, squaring a binomial. Remember, when we square a binomial, it always becomes a FOIL situation. So this is negative 1 minus I root 3 times negative 1 plus I root 3. FOIL this out. We get 1 outer minus I root 3. Why did I change this? I'm sorry. Outer, we get plus I root 3. Inner, we get plus I root 3. And last, we get plus I squared root 9. Begin simplifying. This I squared root 9 becomes negative 1 times 3, or negative 3. 1 minus 3 is negative 2. I root 3 plus I root 3 gives us 2I root 3. Nothing else we can do there to simplify. Last one, just solving this quadratic equation. If we look at trying to factor this, 3 times 5 is 15. Are there factors of 15 that add up to negative 2? Nope. So we need to go to the quadratic formula. X equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. We get 2 plus or minus underneath the radical. 4 times 3 is 12. 12 times 5 is 60. So we have 4 minus 60, which is negative 56. Now, here normally we stop and we say these solutions are not real. Now we know how to handle this situation, so I'm going to go ahead and pull an I out. Root 56 then, we can break down as 4 times 14. Square root of 4 is 2. And now we need to write this in standard form. We get 1/3 plus or minus root 14 over 3 times I, their standard form of that solution.